Okay, for lesson 3-4, this is basically just putting everything together from the first 2 units the first 3 sections and from the very first unit and analyzing these graphs. So basically, here's an example. Here's one graph, and we are going to analyze the graph, so list all the attributes of this graph. There are going to be a couple that are later on in this section and in your assignment where you're not necessarily going to know exactly where that minimum and maximum point is. On those, I estimated them using my calculator on the assignment when I posted the key, but I actually don't care if you want to skip those. I'll show you later on in this lesson. So, first of all, domain should be from negative infinity to positive infinity. And the range, if we're coming from bottom to top, starts at, I'm going to write this point in here so that we know what it is. That point is -1, -9. So the range is starting at -9 with a bracket from -9 to infinity. It is increasing from -1 to infinity. Remember, you can have a parenthesis or brackets on the increasing and decreasing. It's decreasing from negative infinity to -1. And we'll just go over here. So the end behavior, the right end behavior right hand, that's what that means, would be the limit of f of x as x goes to the right. So as I go to the right, my graph is pointing up, so that's going to go to positive infinity. And the same thing for the left hand behavior. The limit of f of x as x goes to negative infinity, which is to the left, is going to also be to positive infinity. There is no minimum. So you can write none, you can write NA, you can just leave it blank. Oh, shoot, sorry. That is for maximum. There's no maximum. But there is a minimum, and you could list it at -1, -9, or you could just say -9, or you could say y equals -9. The symmetry is neither because the vertex is not on the y-axis. It would be even if the symmetry, or if the vertex were on the y-axis, but it is not, so that would be neither. You guys don't have this graph, but just to talk about and review end behavior, if you want to go ahead and graph these on your calculator, we'll look at them together. So we have x cubed minus 4x squared. So clear this out. X cubed minus 4x squared. The next part is minus 5x minus 3. So we are going to graph that, and then we're just going to graph x cubed, the parent function x cubed. So if I hit graph and I look at this, it's going to show me both graphs. There's the first graph, and then the second graph is just the parent function of x cubed. And as I zoom out, so I'm going to hit zoom and then number 3 and then hit enter, it'll zoom it out. I'm going to zoom out a couple times. So, well, maybe a couple times. We'll see how it looks. There's that first graph, and the parent function x cubed is right there. If I zoom out one more time, so hit zoom and 3 and enter, then basically what we're looking at, we're trying to see if what the end behavior looks like. So if you notice, the blue graph is going down on the left side and up on the right side, and it's really skinny. And the red graph is almost going to be right on top of that as we continue to zoom out at the end behavior. So the end behavior is going to do the same thing for any cubic function, any degree 3 function. If you want to reset your window, hit zoom and then 6, and that will reset it so that it's back looking like you're used to having it. So as we continue to zoom out, the end behaviors line up, and each end is going, well, the left end is going down and the right end is going up. So for an odd, here's a couple things to note. For an odd degree function, and you guys have this slide, so for an odd degree, the left and right ends go in opposite directions. So it should be increasing if it has a positive coefficient, and then decreasing if it has a negative. So I mean, it should be going like that if it's positive, and like that if it's negative. So increasing and decreasing, left end and right end. And then if it's an even degree polynomial, both of them are going to go in the same directions. If it's positive, the end behaviors will both be pointed up. If it's negative, both the end behaviors will be pointed down. So there's those listed out for you if you want to check them. You guys already know the mathematical notation, but that's how it looks. So if I'm looking at this, it says name the degree and the sign of the coefficient of the leading term based on the end behavior. So this first graph is decreasing. It is going down as we go across. And we can count the zero. So we should know that it's going to be odd because the end behaviors are different. But this 0 right here is a bounce, which means it has a multiplicity of 2. That one is a 1, so that means it technically has 3 zeros, which is going to make it a degree 3. Well, minimum degree 3. And I say that because it could be like a degree 5 or 7. We don't know really technically if that multiplicity is 2 or 4 or 6. But minimum degree 3, and the coefficient, since it's decreasing, the coefficient is going to be negative. So I'm going to write it like this. So the coefficient is negative. On this next one, we have both end behaviors are going the same direction, which means it's going to be an even degree. And if we count the degree, or count our zeros, that's a multiplicity of 1. That's a multiplicity 2. And then I can't really see with my drawing. That looks like a multiplicity 1 as well. So we're going to say the degree is 4. And if they're both going up, then it is positive. And then this last one, they're both going down. You're going to have an even degree if you count them. 1, 2, 3, 4. We'll say a degree 4. And the sign on the leading coefficient would be negative. So that's how you can tell. I'm going to use that when I'm talking about and describing end behavior for these functions. So first example, we have find all the zeros, graph, and analyze, including the end behavior using limits. So if we don't know, these are going to be the ones, let's graph it first. So this is kind of back from section 2. Our zeros are 1 with a multiplicity of 1, negative 2 with a multiplicity of 1, and negative 3 with a multiplicity of 1. So I'm just going to make some marks on my graph. 1, 2, 3. We have a 0 at 3. We have a negative 3, a 0 at negative 2, and a 0 at 1. And in order to graph it, you gotta see what the degree is. So each of these have a power of 1, so you add up all the powers to decide the degree. So this is a degree 3, and at the beginning there's not a negative sign right there, so it's going to have a positive leading coefficient. So a degree 3 in positive means that you should know it is increasing. So they are all multiplicities of 1, so it's going to go straight through, straight through, straight through, and look similar to that. So we can list the domain. The domain is negative infinity to positive infinity. We can list the range, also negative infinity to positive infinity. Here is where you are welcome to either use a calculator or you can just skip these ones on your assignment. So the increasing, it would be increasing from here to wherever that changes direction, as well as from wherever this changes direction up there. If you use your calculator, you can find what this point is and find what this point is, but if we're just sketching it, we aren't going to know that. So I'm not going to include the increasing. You could do the same thing for decreasing. It would just be that part right there, but I'm not going to make you look that up if we're just sketching these by hand. It is not going to have any symmetry. The only time that it might is if it goes through 0, 0, then it may have some symmetry. So then again with maximums and minimums, since you don't actually know what the points are, list what types and how many you have of each type. So remember, there are relative minimums and maximums, and there are absolute. There are no absolute mins or maxes here, but there is one relative maximum, which would be right here, and one relative minimum, which would be down here. If you use a calculator and you want to list those points, you could, but I'm not going to require you to do those ones, or at least require you to list the actual value for those on the assignment. Okay, and then the last thing, end behavior, we'll say the limit of f of x as x goes to negative infinity should go to negative infinity because it's an odd function. And then the limit of f of x as x goes to positive infinity is equal to positive infinity. So if the degree is an odd number, then and positive, then the end behaviors match what the x's are doing. So if it's going to negative infinity, approaching it for the x's, it's going to go to negative infinity with the y's, and likewise with the right end behavior. So, this is just another type of example. We're really just combining the last two sections. Today is going to be really short. You should have time to review for your formative assessment, which will be next time. So, graphing and analyzing these graphs. So here, it's given to us in factor form. So your zeros are 2 with, if you notice, it's a multiplicity of 3, and negative 1 with a multiplicity of 2. So I'm going to go ahead and graph this. So at negative 1, I have a 0, and at 2, I have a 0. And it is, if you don't remember what multiplicity 3 is, that means it's an inflection point, or an inflection at that point, at that 0. And a multiplicity of 2 is going to be a bounce. So I also should look for my end behavior. So this is a degree, if I count up all of the 3 and the 2, that would be a degree 5, which means it's odd, and there's not a negative out in front, so it should have a positive. So that should be an increasing graph, so it should tentatively look like that. So with this negative 1, it's a bounce. So I'm going to come up, I'm going to bounce off that, and then here is a little weird slide through or inflection. So it slides through that, and that's about what the graph should look. So once again, on this one, you can say the domain and range, negative infinity to positive infinity, negative infinity to positive infinity. You do not need to list where it's increasing, decreasing. And then with maximums and minimums, same thing, just list one relative, and there would be one relative minimum as well. And then symmetry is going to be neither. And the end behavior would be the limit of f of x as x goes to negative infinity is equal to negative infinity. And the limit of f of x as x goes to positive infinity is positive infinity. Okay, and then this last one is one that we are completely combining everything with. I know all of the analyzing. Oh, are they listed on here for you? Oh yeah, they're just down there a little bit. So, with this one, I gave you some room to work. So to graph it, you got to find the zeros. You could use the rational roots theorem, or you could graph it, find the first 0, and then make sure you can factor it. So, if I were to graph it and find one of the zeros, then I could see that I would have. Sorry, 1 second. So I would see that what number I need to use in synthetic division to be able to figure out my other factors. So if you graph it on your own calculator, I'm not going to do it up here, but if you graph it on your own, it goes through negative 3. So I'm going to just start with negative 3, use that as my 0. So negative 3, well, I'd have 1, negative 4, negative 11, and 30. And then I would drop down the 1. 1 times negative 3 is negative 3. That'd be negative 7 times 3 is 21. That'd be 10. 10 times negative 3 is negative 30, which gives me 0, which is great news. So that negative 3 is going to be one of my zeros, and then I can add in the rest of this and factor here. That should factor to be x minus 2 and x minus 5. And then my original factor that I started with would be x plus 3. So to list all the zeros, x is equal to negative 3 with a multiplicity of 1, x is equal to positive 2 with a multiplicity of 1, and x is equal to 5 with a multiplicity of 1. So we could have looked at the beginning before we even started to determine the end behavior. So if it's an odd function, so it's a degree 3, and positive coefficient, going to be similar to the other one. Sorry, there are no even functions in these examples, but oh well. So we would have a 0 at negative 3, we'd have a 0 at positive 2, and a 0 at 5. And they're all straight through, so it's going to come up, go through, come up, and look something like that. So pretty much everything is going to be the same as the slide before, every attribute of this one. So you can go ahead and spend the rest of the time working on your assignment, You do not need to do the increasing and decreasing. And some of the yeah. And even a couple of the ranges. You can use your calculator to figure out those points. You want to estimate it, and that's what's on the key, but you don't have to do that.